After checking the motor connections, the next step is to now set the encoder pulse per revolution parameter. Now, just a note, all this, any variable or parameter you see with this star in front of it, it means it is being stored on the microcontroller, on the PID driver module. These are variables that are being stored, while the ones that without star are variables that are being used by the GUI just for necessary computation on the client side. But these ones are stored on the microcontroller, on the PID driver module automatically. So to set the pulse per revolution, we can start with an initial value, which is this, which is the initial value that is here, 1000. Or you can also set initial value based on calculation from your data sheet. Calculation from data sheets. So this is how to get that from your data sheet. Using your data sheet to calculate the initial value, you have to multiply your gear ratio times the motor PPR on the data sheet. So the gets the initial PPR that you enter into the initial PPR you enter into the application. So based on the motor I'm using, this is how I calculated mine. The encoder PPR, the PPR is 12, and the gear ratio is 90 because I'm using the Metal gear version. So that's how I got the 1080. The 1080. So I'm going to be, instead of using, this is a default value, you understand? But I can decide to enter that as initial pulse per revolution, and automatically it will update on the on this module. It will update it on this module, on the driver module. We'll update it and return it back on the application. That's just how it works. Now, what we want to check now, we want to look at the actual motor. Also want to check the virtual motor. We want to check whether when we command it, one will be fast, whether the virtual is faster than the actual, or the virtual leads the actual. Or we are checking is it slower than the actual, or does it lag behind the actual? Those are the things we are just basically checking. We want to ensure that it's not lagging behind or it's not leading. They are moving at the same speed and they stop at the same point. So that's basically that's what we want to check. That's what we are trying to test with the PPR, which is very important before we go into the PID process. So the first step to do this now, we are going to choose a very low PWM value. We want a very, very low PWM value. Let me try 80. Very low PWM value. Okay, let me stop it. Let me try 75. Just try and use something very low, as much as your motor can take. Yeah, I think I like this. This is low. It's easy for me to monitor with my eyes and things like that. So I can stop the motor. So this is our initial value. This is the initial value we are using. If the virtual motor leads the actual motor, that is, if the virtual motor seems faster than the actual motor, then you have to increase this PPR. You understand? But if the virtual motor is lagging behind the actual, if the virtual is slower than the actual, then you reduce the PPR. That's just basically what you need to take note of. Just for a second, let me start with something a bit lower. Let me use like 800 for an initial value. So the first step is to align the actual motor to the center. Try and align it to the center. Then on the virtual, click on this reset and so that it will also be aligned. Then send the velocity. I want you to notice something. Notice that now this actual motor the virtual motor is faster than the actual motor. The virtual is faster than the actual. So because of that, we have to increase it. So I'll go back to my previous initial. I'll have to increase it. So once I increase it, I reset this back again to the center. I reset the hand also. Then start the motor to see. Yeah, you notice in different, since it's almost they are following each other at quite similar rates. Yes, this is quite okay. Obviously, I'm going to increase it again, maybe 1,200. I'll put it back. Reset the hand and start the motor. I want you to notice something. Notice now that the actual motor, this is faster than the virtual motor, this. Yeah, you notice that now. So that means I'll have to reduce it. So just to reduce it, let me go back to 1090. Set the hand. I set this also. I set the hand also. Then I start the motor. Yeah, you see that this is even much better. They follow each other very well. Very, very, very well. That's what we want. You keep increasing, just check. Just to be sure that you have the right PPR. Because sometimes what the data sheet might not be able to believe in the actual motor will not be as what is stated in the data sheet. So that's why there is option of changing the values just to be sure that you have the right value. So not to waste time, when I did all the tests, I arrived at, for this particular motor, 1092.5. That's what I arrived at, which works very well with it. I'll reset the hand and just do the final test. So with this now, I have the Encoder PPR, and the beauty of this is that once you have this, if you have the same motor with you, you just need to write this value somewhere for this particular motor. So anytime you're using that particular motor, you just enter the particular PPR and it will work for it. So that's just it. Any other motor like this, just use the same PPR, it will work for it. So that's the beauty of it. Now once this is done, then we can now go to the next step.